I want you to talk. Sometimes I can code and maybe I forget even to place a comma or something, the quotation, the opening and closing. So you just talk and tell me you've forgotten this. And also if I confuse at some point, you can correct me and let's work together. Thank you.
Okay, so guys, if you have a question or a comment, just unmute and speak. Thank you.
Okay, so the first topic was the big O notation. So we need to discuss the big O notation. So basically, when you talk about the big O notation, it describes the complexity and performance of the algorithm. Like how is it complex and how is an algorithm performing? So for example, if you have written down your algorithm, you need to know how that algorithm will perform or how the time it will use for it to execute. So that is definitely what big O is all about. So under the performance, here we actually just look at the time, the memory, the capacity that is required for it to run. And for complexity, here you as the person is coding or as a programmer, you should be asking yourself the performance requirements that are required to increase the input of the algorithm that you're going to write down. Okay, so for example, we have the different types of big O notations, because most of the time the big O notations are always represented in mathematical expressions. So just keep in mind that when you are dealing with big O notations, just taken to run the algorithm and the space complexity, which the extra memory space required by the algorithm to run. So you need to put those two considerations into place. So you need to check on the time complexity and you need to check on the space complexity of the algorithm. So most of the time, as I've said, the big O notation usually uses mathematical expressions such as O1, we have ON, we have ON squared. Somebody can say ON raised to 3, ON raised to 4, ON log n, or n into bracket n log n as you go by and as time goes by. So the only trick here is that you want to know if this is a worst case scenario of how your algorithm is going to perform. So basically, we'll start by talking about the first big O notation, which is O1, and this is always referred to as the constant, because I think I wrote small n, so it's supposed to be capital N, then 1. Yeah. So let me just comment it. So basically, under the O1, here the number of operations that this algorithm is performing, it remains the same. So this means that if you've written your algorithm, no matter the number of times you'll keep on adding anything on the code. Let's say maybe you had a list, and let's say the listed colors, let's say red, blue, yellow, brown. But if you write an algorithm that has the notation of O1, it only returns a constant, because it remains constant, because no matter how much you add on the input size, that is the space, there is no change that will occur on that algorithm. So for example, I can illustrate this. So let's say we have a list called colors. Just a minute. So let's say you have colors. So let's say we have green. Then somebody has red. Then the list has red. Then let's say we have pink. Then I can add blue. So let's say this is the list that we have. So we can create an O1 algorithm. So let's say you'll define a constant. Then we place the argument colors. So you can print the colors Then let's say you're looking at the index. Let's say you want to print at index, let's say 2. So if we print, we call the function because we define the function. So let's call the function constant. Then colors. So if you run this, you see you are getting pink because this is at index 2 we have pink. But let's say you add something like, let's say we add any other color. Let's say we have purple. Then let's say somebody adds in even a color like violet. So if you run this algorithm, you notice that still you are ending up getting pink because no matter how many operations how many colors you'll add on this list, it will just perform that one operation, which is index at number 2. Even if you change at index number 3, no matter the colors you add, even if they are 100, it will just perform that, it will just perform it once. So that is what we call by the O1, which is the constant or big notation. Who has not understood, or if you want me to use another example, you can ask me and then I go ahead. But if you understood, you can just say okay, then you go to the next one.
Can you use another example?
Okay, thank you. Where was I? Here. So let's say we have another example. So let's say maybe let's define something like constant. Let's this time call this one constant function. Don't mind my spelling, some poor at typing. So function, then let's define an argument, let's say my list. Okay, so you can return. So we want just to return. You can say you want to return. Let's say maybe you have a list. Maybe it has 1, 0, 2, 10, or it has 10 digits, 10 different digits in it, and you want to return maybe a digit that is at index 5. You see, this is something that is just occurring once. Like the algorithm will just perform the operation once. It will not go on going to perform another operation because that is only something that we need from this algorithm. So let's say maybe you want to return my list. Then let's say at index 5. Let's just say that. So we can try. Let's say my list. Then we have 0, 7. Let's just guess 5, 8, 9, 10, maybe 19. So we can say result is equals to constant function. Then we call my list. And then we can print the result. I don't know if my spellings are okay. Let me check. Constant. So I didn't place the how is it called? So that is it. You see, like this is an algorithm that if you check, it is only performing like one operation. So no matter how you come here, even on this list, let's say you add 100, you add 34, you add 67, you add 45, still when you run it, it will still give you 19 because that is what you've instructed your algorithm to do. So this is an example of an O1 algorithm. So it's notation O1 because it's only performing one operation. Yeah. So I don't know if you've understood.
Yes, I've understood.
Okay. Any other person who has not understood before I go on? Like any person who is having problems to understand what is happening?
Linda.
Okay.
So if you have, let's say you have 2 lists, would this apply?
Yeah, it will apply, but the output will give you 2 because if you have another list here, it means that you have to return my list. Then for the first list, maybe you'll have list 1, then you'll have list 2. So when it goes through the 2 lists, maybe here it will give 19, then the next output will give 20. So that means it went in the first list once, then it went in the second list once. But remember, it's 2 lists, but the algorithm is 1. So still it's all one notation because it goes through one list once. Because the goal here is it performs only one operation.
Okay.
Yeah.
Thank you.
Welcome. Any other person? Okay, I think everyone is good. So let's go to big notation ON. If I'm fast, you just tell me because I usually talk faster. Okay, so when you go to ON, so for ON, this follows a linear path. I don't know where was that diagram. I don't know if I can get it so that we just show it. It was looking like. But I hope many of you know how a linear path looks like. I don't want to download it because I downloaded it. So here it is. You see, it just goes straight. Like O is ON. It's that linear path. Like it's like a linear path. So it follows a linear path. This means that the number of operation increases proportionally with increase in the input. So that is the ON. So definitely after that, we just go ahead and maybe do an example and see if people will get it. So let's try. I just want to use this one. Just want to use this list so that it becomes easy. So let's define the function to be linear. Then colors. Then for color, I'll explain the algorithm, don't worry. So for color in colors, or somebody can say for I in I, print color. And then we need to call the function. I hope my screen is big enough. Is it?
Yeah, your screen is clear.
Okay, thank you. So for ON, this is the one we are saying it follows a linear path. This means that, for example, if you check here after you've defined the function, then you come and iterate. So there is a for loop, and for loop we said from the beginning when Nehemiah taught us that it iterates through the list that you want to do. It's because here the list is the colors. So it comes and iterates for color in colors. So it goes from one color to the next, to the next, to the next. Then it prints it. This means that if you have like 10 colors, it will print 10 colors. If you have like 100 colors, your output will have 100 colors because it will just go to that list. Even if these were numbers, it will return all the numbers because for I in maybe list, print list, like then print result. So it goes, then it picks each one of them, like it iterates and then it returns each one of them. Because the size of it, this is 1, 2, 3, 4, 5, 6. The size of the input, like the number of elements in which the algorithm needs to act. So definitely for ON, you see it goes for color in colors. It picks green. It means even when you add here yellow will be output. It will add an output here. If you add what, so no matter the number of items in the list, that is what the algorithm will return back. Yeah. So I don't know if you get it. So this means that it follows a linear path.
If we are to pick pink like the first example, using this function, we want pink. Would we still call it a linear?
No, because if you want pink, that means you are only carrying one operation to give you pink. You see? And that is what distinguishes it from this first algorithm. Because you see here, we were just saying we want the index 2, and index 2 here is pink. But when you come here, the fact that we've introduced the for loop, it iterates through the colors, this list, then it brings every color in that list. So that means it's bringing this n that is here in. Then I can write it n small, also it works. So this n that is here, that are the number of elements in that list. So it gives you each and every element. So that means the more the number of elements will be, the longer the size of your output will be. Yeah. Have you gotten it?
Yes. So in essence, what you are saying is, if we are looking for an element, one element maybe in a list, that means it's a constant complexity. But if we want everything in the list, or maybe some elements in the list, that's linear.
Yeah.
Okay. Thank you.
Welcome. Any other
question?
Okay.
So maybe I have maybe there's a list of sometimes maybe you have a list of maybe thousands, or maybe you see maybe you have a big list when you are dealing with let's say a real life situation.
Yes.
So, and you want maybe a specific you want to maybe filter out the data so that maybe you get a smaller data that you can work on when maybe you are trying to analyze your data.
Yes.
So which option should the one use? Should the one use the first one or the second option?
No, now you see, like the first one you can use the first one if you want just, let's say, one or two, but there are other more big annotations that you're going to look out that maybe will make things easier. You don't have to repeat yourself, like we'll meet even the one that you can just pick. You can just write an algorithm that can iterate and iterate and iterate. But most of the time, big O notations they usually have worst case scenario. They have one case scenario. There's another notation that is called omega. Omega is the one that usually has best scenario, but we will not talk about that. But big O notations most of the time will have a worst case scenario. So for you as a programmer, you need to look at which one is appropriate, because if you look like this ON, it will take you years and years. Let's say if somebody gives you data that is huge, you see, even your computer can hang at some point. So it's up to you to choose which one is the best. But as we are going by, the more we learn and know how, and even reach where we have to search for a certain element or a certain index number from a list or an array, we'll understand to know how we can reduce the complexity and check which one has the best case scenario and which one will give us the good fit scenario. Yeah. But for now, if you compare these two, this one is the best, because if somebody wanted to take violet, it's easier for them just to call the color violet. But for this one, they have to iterate through the entire list, then print them out, then know where purple is appearing.
I think that's fine.
Thank you. Okay, if there's no other question, I think we'll move to the next big annotation, which is O. I hope everyone is understanding so that we are on the same page. Okay, so this one, let me write here because people can want so this one you said it's linear, then this one you said it's constant. It follows a constant. Let me just put constant. Then this one, it's called quadratic. I think you people know quadratic, or we learned about quadratic equations. Quadratic. That is the spelling. Yeah. So for
I think the best formula to use there is to use maybe the upper what, so that you can show it's kind of a power.
Pardon?
Instead of just
Yeah,
typing
please.
N2. instead of just typing N2, you could use instead of typing that N2, you could add
Oh,
so that people can know that it's a power.
I raise it.
Yes. So that people can know that it's a power, because you can have power of 2, 3, and so forth.
Yeah. Okay. Thank you so much for that. Okay. So for the quadratic, as per the description, they say it describes an algorithm whose performance is directly proportional to the square of the size of the input. So you see, this n, the n is, I told you, is the elements that are supposed to be the number of elements upon which the algorithm needs to be executed. So that means that for quadratic, it means that the algorithm, like the performance of this algorithm, will be directly proportional to the square, now to the square of that n. So that is why it's n raised to 2. So let's try to implement using an algorithm and see how it will work. So let's say, so let me reduce the color so that I can even stop at blue. So we can define using the quadratic function, then colors, then you can say for first in color, then we go and iterate again. So here because the n, it's directly proportional to the square of the n. So you see, like you call out first the first iteration, you write the first iteration so that it checks the you can say for I in color, or for, you can say anything. So for example, for I in, this should be colors. Then you go ahead and iterate the second time, because now you are looking at it in a directly proportional way to the square of n, like the n becomes twice, like twice, because it's not one. You see here it was one, it just went for color in colors, then print color. But here you see for first in colors, then you go the second time. If it's n raised to 3, you say for first in colors, for second in colors, for third in colors, for fourth in colors, like that, until even if it's 100 to 100th times. And you see that will be a very big algorithm. So let's
Linda,
try and see if it will work. Yes.
I think also maybe to add on what you said. So this one depends
Okay.
if you have the nested list. So sometimes when
Yes.
when we reach to a module called NumPy, we shall talk about the dimensional arrays. But now in this case, we are talking about the nested lists. So the number of iteration now also depends on the number of the nested loops. So for example, if you want to iterate the outer loop, you use the first for loop. But if you have another list, in that list, for example, if it's a one dimensional array or a list, then you'll use the second now for loop. So this number of the for loops also, it is dependent on the number of the nested things, nested lists, or object can be a tuple, a dictionary, and so forth.
Yeah. Okay, thank you so much.
Excuse.
Okay.
Nehemiah, can you repeat what you've said? It is used for?
Now, when you use these for loops, now assuming that you have a list, and in that list it has another list, another nested list. So the first for loop, remember the for loop, the for is for iteration, for iterating things. So for example, you have the first iteration, you use the first for loop. Now for the next, for the second iteration, it will be targeting the inner loop. That's when you'll use the second for loop. I don't know if I'm clear on that.
Yes, thank you. I've understood.
Okay, welcome.
Okay. So as Nehemiah said, that's how it is. So you'll iterate the outer loop to check in the list, because this is a list. And then you iterate the second time to check. Then now you print you should print the first iteration and the second iteration from the loop. So let's say if we call the function, how will it be? How it look like? So let's call quadratic, then colors. The spelling quadratic. I hope the spelling is okay. There's a problem with spelling. Yeah. So you see what it does? It goes from on the first one, it picks green, then the inner loop also picks green. Then it goes green, red, green, pink, green, blue. Then when it reaches here, it goes red, 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 pink, red, green, red, blue. So I think Nehemiah, maybe you can explain to them how that one works.
All right. So I think what you'll do, try to create a two-dimensional array, to create a nested list. You know, I'm used to NumPy, so I usually call it arrays. But just create a nested list, a list inside another list. For example, a list that contains, for example, 3 other lists.
So on a new cell.
On the same list, on the same object that you've defined their colors. What you do, you see that part where you have the colors, or maybe if you don't want to, like people are writing things, you can create a new cell. Perhaps you can copy just in a new cell, and then you'll open. Yeah, so define your color. Sorry. It wasn't defining, but it's to create your object with a variable. For example, or let me use let's try to think of something that can be, can make sense. Or just use colors. Just define colors variable. And then, so that's how you define a list. And sorry, don't add the quotes. Remove. So this is the outer list. So this is how you define the list, but at the moment it's like an empty list. But now inside this list you're going to create another list. So you can open and close another like that. Then you can add in, for example, you can categorize. For example, I'm trying to think of a better thing to use. Or it could be like, for example, if you want to group, for example, the cereals, fruits, and stuff like that. So you want to list related stuffs maybe together. Because I want it to like make sense. Or I'll just list there, for example, the fruits. Then in another list, you list something else. Or maybe cars. The essence just people to understand, not to.
Different types of green, different shades of green.
Yeah. Because I want to create like at the first list in our list is contains what fruits, for instance. Yeah, so that can be enough. Yeah, and then So and then after that list, so in that before you close that. So that inner list. So that inner list is going to be like our first element. So there, and then you add a comma, the way you separate, parameters. Then you open and close the list. The list, how you define the list with the open and square brackets, the square brackets. Just use where you are, that way. Then there you can list other things. For example, you can
What about Nehemiah? We use,
Yes.
let's say, like vehicles. Like, let's say if it's a Toyota,
Yes.
maybe Toyota with, let's say, a color red of Toyota.
Mm.
Yeah, first list is the name of the vehicle. The second one is the color.
But no problem, because we don't want, provided people do understand, we don't like want to give Linda a lot of tasks to type things. So I think the main idea is people to understand how to like iterate these things. But in reality, when you are doing something in real life, you try to be somehow creative, you know. So essentially, what she was trying to like illustrate there, when you have that, you know, quadratic in the big O notation, when you are trying to illustrate here. So the first for loop iterates the outer list. So now the second iteration will be targeting now these inner loops.
This one.
Inner loops, yeah. So the loops inside these the other list. So basically that's what it usually target. It can be a list, a tuple, a dictionary, or things like that. So it depends with. So like first of all, it will take time to iterate the outer loop, right? And then the other time it will take, how can I put it? Like the first iteration occurs in the outer sides, so the second iteration occurs in the inner side. So for example, if you had another nested loops inside the list, then it will go another dimension to iterate that inner loop. So it depends with the number of powers. Powers there is like the number of the lists inside the list. So the first is the outer, and if you have power 2, it means that you have the only 2 lists. But if it's power 3, it means that we have 3 nested lists. So it will go 3 levels. So you can see that it may take sometimes, for example, if you have a lot of the nested lists. I don't know if you are understanding, guys. So essentially that power thing is to like determine the levels of those lists inside the list. Yes, please.
Nehemiah,
Yes.
is it possible for you, from explanation,
Yes.
to ask Linda
Mm.
to like write something that you're explaining, then she runs it so that we understand? Because personally, I'm not even getting what's going on. Though I'm not feeling well today, that's why I'm a bit quiet.
Yeah, Linda, you can try maybe.
Okay, so this is the list. So what is your defining function for you?
You can use just anything. You remember I told you last time that I'm not creative.
So you
I'm
can
not
say
that creative.
okay,
Mm.
you can say quadratic. Then let's just use the colors.
Mm.
So from there,
So the first iteration,
because
you can say, for example, let's say for colors, what can you call it? Yeah, just call
for
it.
fruits,
Yeah, say just call it
or we
fruit.
can use I and J. For
Yeah,
I,
yeah. For I in
colors.
yes, in colors. In colors. So that's there, and then you do there to
Also,
like yeah. And then now for the second one, you can use for J in still colors, but now you are targeting you are targeting, for example, the elements that are, for example, the list. For example, list number 1 is index number 0, right? So you say colors, and then inside the square brackets, you define the index that you are trying to like iterate.
So you can say 2.
Yes, yeah, you can say, for example, no, we don't have like in that list we have 0 and a 1. Remember, indexing in Python begins from
Yeah.
0, yeah. So 0 is the first element. and then you can do some what? What can you do there? Just iteration only, or we can do some condition there to like, or it's
Yeah, you
just
can say
say
if I is
print.
equals to J.
Or what you do, because the aim here is to like target the iteration things.
You understand?
Yeah, just
Yeah.
do print. Just do print what? Print colors.
You can just call the function.
No, first of all, you can print. We shall call it, or you can call it. Then I shall revert back to the upper side so that we can talk about it.
Okay.
Someone like me who is not good in spellings, I could have just copied the exact name.
Yeah.
And then so there the print function there before.
Why is it red?
Yes. So I think what you do, you don't have to add in the colors because you had already defined it. Remember that Python can as well return objects without the arguments.
Yeah.
So give it an empty. Also the other side, the other one on the function definition, remove it. And then now here, the last four, the last what? Yeah,
This
you
one
can
doesn't have.
add in the colon. Then you can say print colors. Print colors. Yeah. So I guess things are good. So you can try to like run and see.
Is this supposed to be red? Why is it red?
Did you use the exact name?
Yes.
Let's try to let me see. Can you try to use the return statement instead? No, but we are trying like or what you do?
Can you
What you
that?
do? Can you try to add in the arguments there? So instead that part of the, for example, that quadratic something. Yeah, you can create a variable there. I think so. Just pass there, for example, colors.
Then
because we've
colors
used.
will be this one.
Let me try to be like logical so that people can understand what I'm talking about. So I think what you do. So you see that part where we have the parentheses. The first in the definition, just type their colors, the way you had written colors. Yeah, colors, and then when calling the function, you can remove the long name there. Just remove the last line.
This one.
Yeah, you can remove it, and then our variable to distinguish, you can call it, for example, fruits. So instead of colors, call it a fruits, and then also remove the first part of the colors, and then copy the list. Copy the list. The list that you have there. Yeah. Just no, yeah, that one at the top for fruits there. Just copy everything, the entire thing the way it is, instead of that part. Like what I'm trying to do is like to pull that content the other side to this part.
I pick up to here.
Yeah, everything. And then in the function, when you are calling the function, call it, for example, you can pass their fruits. So you'll copy the code something. then
Mm-hmm.
on the argument there you'll pass in the fruits. Yeah, try and
Yeah.
yeah. So basically, so you can try to explain or so basically what it did. So the first iteration is for the outer you know
This
the
one.
outer, yes. So and then the second iteration is for it's for the inner iteration, but we haven't.
Nehemiah,
Yes,
the first iteration
yes.
is for what? The second iteration for what? Because when you say inner, and I can say for J in colors,
Oh, sure.
is the first list,
Yes.
meaning the second list is list number 1.
Yes.
Yeah.
Yeah, I don't understand that.
Oh, sure. So, let me try to put it very well. So you can see, like when you are defining these for loop. So after you've defined a for loop, so the next thing should be the block of code inside that for loop. So it means that any iteration or any code that should be in the for loop should have some indentation to show that is the code inside that a for loop. So the first one, when you have for I in colors, so it means that anything that is in, so the first one, it means that it's going to iterate the outer list. For I in colors, it's going to iterate the outer list. So the outer list is this list where we have Oralinda, what you do, can you try to like cut the first and the second list so that people can so I can describe well.
I go to the first one.
So
This one.
that part of the colors, yeah, any yeah. So cut that part of the where we have those inner lists, both of them. Just cut all of them from the first to the second one. Just cut.
Like this.
No, cut only the inner lists.
The inner list is this one.
Yeah, and then up to the end, up to. But what you do, just
Linda.
Yes.
Do this from where you started, where the first list starts.
This one: tomatoes, oranges, apple.
Yeah, start from
here.
No, you're cutting. Okay, in simple terms, just leave the outer bracket only. Nothing else delete.
Yeah, cut that. Yeah, cut.
Yeah, like that.
Cut, yeah. You can cut. Yeah, so basically this thing that you see, like it is an empty list. So this is the outer list. But inside, so now when you paste, you will have done what? How can I put it? You will have added 2 other lists inside this list. Initially it was empty, but now you add in 2 other lists. So this is why we call it the nested list. So the list that are inside another list. So we've just used a scenario where we have one level of or a one dimension of list, where a list has other lists, but it can also have like a three levels of different lists. You can paste there so basically that was the outer list. But now inside that list we also have other lists. The first list contains tomato, oranges, and apples, and then the second one is Toyota, Volvo, Isuzu.
So in short, it means that the outer loop iterates through the list that you had left, the empty list.
Yes, the outer loop.
Then it gives out the size of the input, like it iterates through it. Then for the inner loop, it iterates through elements now in the list.
Yes.
For every outer loop iteration.
Yes.
Then for each iteration of the outer loop, now the inner loop will perform additional iterations to the outer loop.
Yes.
Okay.
Yeah, so this is why they call it power. You have power. So each iteration, it has what? It has like a 2. So in each iteration, it's going to, like you can see even the output. Output display it well. Like in each iteration, we are producing 2 other lists. So it's going to do 2 iterations. So it is like factorial. It's not factorial, like power. It's doing the power. So it depends with the number of the lists you have, the nested lists you have. So that's the reason I think people now understand why that power is coming from. I've just used an example of a list, but it can as well work with the other data structures like the tuples, dictionary, and so forth. Yeah, so that's what I wanted to add on.
Yeah, thank you for that. And it's even the first one is just doing the same thing. It's because here the list was just like something like our one list. It doesn't have, like, how can I say it? Like, it's just a list. We don't have another list inside this list. So it just iterated the outer loop, iterated first on the list, then the inner loop went ahead and iterated again on that list that the outer loop did. Yeah. So I don't know if I've confused you.
Basically, maybe to add on what you said, because you defined colors, like you did 2 iterations, like you are doing the same iteration on the same things. So
Yeah.
basically, the first one is going to iterate the list, is going to iterate the elements of the list. But now because we have other things, it's going to go into another level to iterate the same things.
Yeah.
Yeah, because you've defined colors, you don't have the nested list. That's why it's going to do that way.
Yeah. Any person with a question before we move on?
Me. Okay. When we say for I in colors and for J in sijui colors, these I's and J's, what are they representing? I've seen them in so many lists. I don't even know what exactly they are about.
Okay, I'll invite somebody to explain to her.
Okay, and also I think we had an error there, like not an error really, but you could have there printed out something like J instead of colors, because color is like our that's why it returned. But you also wanted to return the 2 dimensions so that people can understand. However, to answer Nemo question, that I is just like a temporary variable. It's just like a variable. You are defining a variable. So like you are going to say that variable is going to stand to stand for the list of elements that's going to be iterated, like the container that's going to be to hold the iterable object that you are going to have. Like, it's just a variable, just like any normal variable. You can use a multi-word, or you can use a word, or you can use these simple things like ij. It's just a variable.
Okay, so what does it do when we say for I in colors? What exactly does for I in colors mean?
It's iterating. So you see these colors, these colors here is these colors. So for I, it's just like a variable. So it goes through that. Even somebody can say like for, somebody could have even said for Jeep in colors, maybe for Nemo in colors, for Linda in colors. So like it's iterating. So that I specifically, like it's going through it's going through the list, like the range of the list one by one, going through it. Like
and
looking through it. Yeah.
And to better explain her, you could have printed out, for example, J. Try to print J alone so that she can understand. Just instead of colors there, where we have colors, just print out J. It will print out the elements of list 1 alone. try to
Yeah.
run it, you can see.
So I and J, I represents list 1, J represents list 2. That's what you mean.
I
Like in a
represent outer loop. The outer list, not it represents the outer list. Like okay,
which
I
is
said,
the outer list.
when you try to
Oh,
cut.
no, Nehemiah.
Mm,
Let me try and explain this.
yeah, please.
When you talk about the outer loop,
Mhm.
I think I hope Nemo understand it. I
Mhm.
believe when you talk about the outer loop, you're talking about you see those two outer brackets. That's like the bigger list carrying
This one
smaller
and
list.
this one.
So the bigger list is the outer loop.
Mhm.
Nehemiah, that's from my understanding. The bigger loop is the outer loop. So for I in colors, for I in the outer loop, then for J, screen remainder.
Sorry.
Sorry for people who don't understand Swahili. When I say screen remainder, I mean the screen has gone or disappeared. Okay, it's back. So when you say for J in colors, then that means that the J now represents the inner lists. Then you are looking at list at index 0. And index 0 is the first inner list that has tomatoes, oranges, and apple.
Mhm.
Right?
Yes.
So for I in colors, I now is like the mother of all. Mama Yao. Mama Yao is the mother of all.
Oh, so for J is what represents like the combine that the two lists inside the mother Mama Yao list.
Yeah. So if
So
I
say J in colors, you index 0, it will just print tomatoes, oranges, and apples.
No, for J in colors at index O. Remember, we can have even 4.
Index 1 or index 0.
Index 0, index 0, sorry, index 0. So we can even have like 4 sub list inside the bigger list. So that's why I think if they use for J in colors, then 1, it's supposed to do the other way around. From my understanding, like
So it is telling. So in other words, this function, it's going to look at the outer list and then go for the inner list. That is what we are telling it.
From my understanding, not unless I'm wrong.
Okay.
Understand to be corrected.
Understood.
Linda,
Yes.
Just print I. I see what it will return.
Okay.
Nehemiah,
Yes, please.
is it possible to check out?
Oh, so when you say I, it will print out everything.
Yeah.
Yes.
But for J, you have to specify like the specific index you want it to print. Is it the first list, the first sub list, or the second sub list? Okay.
And then again,
Can you try to do
something that
on
I
J
forgot
do
here.
1 and then print JVC?
Pardon?
On J, try to do 1.
Yeah.
So that we see what it will print.
Like that.
Yes, print it. So it will bring Toyota. Okay. Now I get that.
Okay, and then before you go ahead, there's a very good question that I think Nemo has raised. What if you don't use any value in there? No 1, no 0. What will happen?
So I think you can define a range, but still also with range.
Will it print the when you don't put anything?
Do it. Let's try.
Yeah, when you don't put anything, what will happen?
It prints the both.
So it actually does Toyota, oranges, apple. Then it goes Toyota, Volvo, Isuzu. Then it goes tomatoes, oranges, apple. Then it goes Toyota, Volvo, Isuzu. And I think now this one now brings in the ON squared for me. Because what is N squared? What is N squared? When N is because here we have how do I say it? Because we have N. If let's say N is 2, that means it should the for loop should go how many times?
twice.
Uh-huh.
So it's basically spreading. So it basically means that for I in color, that's the first N. For J in color, that's the second N.
Yeah, even me, that is how I understood.
So if it were, if we were ending at
Because J is iterating on the outer loop, which is for I in colors. So for I in colors, it's the first iteration that happens. Then J is the additional N. Now it goes to iterate the second time.
Sure, no cap.
Yeah, so
you can simply put
anybody who thinks it's right or it's wrong, you can back up.
Yeah, so
Nema,
yes.
I think PG wants to speak, and she's saying that the mic is not working. I don't know. Maybe she has some insights for us. I don't know how to support her.
Mine or has?
Has.
Okay.
That she cannot use her mic, so I don't know.
She can ask in the chat.
Yeah, she has just done that, but it's still not working.
No, PG should
the
ask.
Microphones. The microphone or what?
Yeah.
So the explanation Ibrahim had said was wrong, or now, or even more confused.
Yeah, I'm wondering. But
now I'm even more confused.
Can I let me try it like to simplify it. So on the big O notation, we can simply put n to be like the number of iteration. You know, the number of iteration that you have. So for example, if you have 2 iteration or a 2 list inside the list, you can say that it's going to do what is going to be power 2. So it's going in 2 levels. The iteration is in 2 levels. So the first level is the outer iteration, and then the next level is the inner iteration. So the number of iterations depends with the number of the loops that not loops, the number of lists, nested lists you have. So basically the n is the number of iteration that you want to like operate, and then the power is like the levels inside. I don't know if I'm confusing people much more trying to explain. And actually we haven't done it in a proper way. We could have used, for example, the range. For example, if you want to iterate or maybe to return only the elements of the first list, but basically the essence.
Hapana ni yako.
Let's try doing this. Let's say maybe we have a list 1, 3, 4, 5, 6, 7, 8. So let's say maybe that is the list that we have. So that means let's just maybe simplify and see if we'll get it. So that means that the outer loop iterates through each element. So it will come in this, let's say this is the element or this is the list. So it will come and iterate through each and every element. Then the number of iterations will be n. That is the first n. Then the inner loop will also go ahead and iterate through each element in the list once for every outer loop iteration. So this means that for each iteration of the outer loop, the inner loop performs n additional iterations like to the ones that the outer loop had done. So let's say maybe the inner loop went and did the iterations, and that is the I we are saying. So J will also go ahead and go through the list and also perform iterations. And for each iteration on the outer loop, the inner loop now performs an n additional. I think that is how we have understood. Unless there is somebody who can simplify it further.
I think that's clear. Maybe to simply put, for example, if you have a basket of fruit, we can call that basket like a fruit. So the first thing, and then those fruits, they are in packets. Like in Kenya, there's a way where you can, for example, pack, for example, some number of fruits. Then you can give it a fixed price with a discount, for example. So you can pack those fruits inside another inside a basket, one basket, right? So when you say the iterations, like you are unpacking, you are removing those fruits packed outside. You are removing those packed elements, and then after you remove those fruits that are packed, then again you are removing the fruit itself from that packed, things. So you can see there's two unpacking, or a two, like a removal of removal of items. So the first one is going to remove the elements which are packed inside what? What can I call it? These carrier bags. Let me put it this way. So, for example, you have fruits that are packed inside the carrier bags that are inside a bucket. For example, a bucket to carry, to carry the fruits. So, the first thing you are going to do is, like, you are going to remove all the fruits that are packed, or you are going to remove the carrier bags containing the fruits from that container. So that's the first removal and packing of those fruits. Then after you remove the fruits, again you are going, not fruits, the carriers, and then the next thing you are going to remove now the fruits itself. I don't know if people are understanding. I think it's clear.
That makes sense, and an example of that is the bubble sort that we look at it when we get there. Then we'll see how this now comes in when we'll start sorting the numbers using the bubble sort. Maybe if somebody will not understand when we'll get there. Yes.
Linda, I don't know, but it seems like you have so many people with questions. So maybe we have to request them just to talk, or people are raising hands, then they have.
Some of us are just hanging.
Okay.
Just ask your
the problem is that when I'm on this page,
I understand. You
I can't see the person who's raising the hand until I come back here.
Yeah, and that's why. And that's why I'm requesting those people. If you have a question, just ask. It's democracy. It's free space. It's free space. Don't fear. Just ask your question. Like a person like Jemo Gidhirwa, you have just raised your hands for
James is my good friend. Yes, James, can you talk?
So for me, my question is, can you please go back to the notebook? Okay, so with this function, aren't we supposed to be printing like the items individually, or why is it that it is repeating twice? You see, like tomatoes, orange, apples, it has been repeated for a second time, and also the other list, as in, shouldn't we be doing it once? I don't know if you get me.
Can I maybe answer that?
Yes.
Now you see just the same way as you can do with the big O and with N. So this one, we are not targeting a particular element. Like you are trying to see the performance of iterating so like for example, if you had the list, so the performance could be the time it will take like to iterate all the elements in the list. But if you could be maybe targeting, for example, a particular items, and then that will be like limited to some certain condition. But here we want to explain that idea of the big O notation where n we have n is powered. So we want essentially to like iterate everything. So for example, if you have maybe many lists, so we want to see the best way, like how we can do it, how we can solve something. So this way we are just trying like to iterate everything. That's why you can see we have it is returning duplicates, it is repeating itself, because I want like to iterate everything, everything, including all the But we could have used the range so that we can limit what is going to be returned there. So basically, the idea of that thing is like we are not in specifying some parts where we want like the way she has done here without the adding the like the indices, the index. It's like she wants to like return everything without some limitation. For example, that one where is direct proportional like a linear. Is it linear? The first one where we had the constant. So the constant, you know what you are going to look. And then for the linear one, like you want to iterate everything, and then search one by one until you see the elements. So with this, with the power also, you don't know. So you want to iterate everything. And that's why it's going to return everything here. But if you could, for example, want to like iterate only some elements of a particular item, you could have used the range, and then it will definitely iterate only the elements of that index that you want to like iterate. I don't know if you've understood.
Yes, I have understood.
Okay.
Okay. The next person with that question. I think Ibrahim, you know them.
I have a question. So, as Nehemiah has explained, if now we want to get the cars list, for example, we just want Toyota, Volvo, and Isuzu, how would the function look like? And we just want it to be just one list, not repeated. How would the function be? And would we still call that quadratic complexity?
No, because you'll have to do away with the outer loop, so you'll just remain with you'll just remain with, I think, one iteration, if I'm not wrong. The fact that you are doing 2 iterations, you have the outer loop and you have the inner loop. That's now what brings out the quadratic time complexity, which is n raised to 2. And by this, it means that if you are iterating, the total number of iterations becomes the product of the size of the input, and the product is the n. So it becomes n times n. So that means that if you want to go through the list and you want to only pick the car, you said the cars, then
Yes.
you just go for J in colors. So that means you wanted to get rid of 4I in colors, we get rid of that?
No, as in, okay, the question still remains the same. Colors, the way we've just done it. But now, in this list that has outer and inner lists, the 2 inner lists, I just want Toyota, Volvo, and Isuzu. How would it be? What function would I write?
Who will you print? JJ.
So I have the exact same thing. Colors is equals to the outer, then the inner. Then now I just, from this list, I want the Toyota, Volvo, and Isuzu without getting rid of the first list.
Can I answer that?
Yes.
Okay, so for that, you'll just say colors, then you specify the index 1. Print colors, then you put like those square brackets and specify the index 1. If you want only to get Toyota, Volvo, Isuzu.
Like that?
Yeah. Can you try?
Yeah.
Yeah.
May I ask us something, Lynn?
Yes.
Now, there is for I, for J. Can you please add another maybe for K in color in the print? And then remove that one, the print function. Then yeah.
Like that?
Yes. Can you please?
What did I do?
Okay, fine.
Sorry, no, it's in the version. So no problem. This now becomes n raised to 3.
Now, if I got Nehemiah well, then it is like the first line 1, that is colors is equal to those lists, yeah? Then to me, it appears that we have got 3 different lists. No, 3, yeah, something of that kind, because we have got the outer square bracket and the 2 inner square brackets.
Nehemiah? Yes.
But if you look at it, there is outer square bracket representing a list. Then we have got the second list is the one that now lists fruits.
This one to here. Then the third one is here to here.
Exactly. Now, I've just requested you to print up to the third, maybe for loop, to represent, okay, does it represent that now n is now raised to power 3?
Yes.
Now, if that could be so, could it also mean that this would be the most appropriate answer? Because if we have got 3 lists up there, then we should be expecting an output that represents, that is a true representation of the, what we may call the question, the first line. Because I and J, something tells me from the explanation and discussions I've had over here that I and J means that we are only raising it to power 2. And so with that, we only look at two lists. And with that, I also tend to imagine that if we're only looking for 2 lists and we have got more than 2 lists, then maybe the function or the inbuilt algorithm will show that first deal with the first list and then go to the second list. Once we are there, stop. And now that is what actually brought that tomatoes, oranges, apple, Toyota, Volvo, Isuzu, tomatoes, oranges, apple, Toyota, Volvo, Isuzu. And so I was wondering if that could be so, then what is the real function of the outer bracket, that is the square bracket, the outermost square bracket? Or can you remove the squaremost outer bracket and then then in that case you'll remove k, this for k, because now there's 2 something. You now run.
Now,
Yes, we are now getting
I think let's try to make this thing clear. Also, maybe to answer the someone that we didn't answer her question. I think it was Lauren. She wanted for example, you want to iterate only the elements of tomatoes. So the idea here that we were trying to explain is to iterate all the loops. But for example, you see this part where we have the colors. So the color is you are trying to access the same. You can see our main variable or our main argument. How can I argument this color? So we are trying to access everything. But we can see the first iteration that we are doing there with the for loops it is taking the arguments of the colors. So in the next 4, we could use now for j in I now, because now that I is the next what, and the next the I is our other variables. But now, so the reason we are doing the color is just to try to iterate everything. But if you wanted to to answer Lauren, for example, to iterate only the elements of the first of the first element, you could have used instead of that part, the second place where we have the colors, you could have used that I, because I said that this I, J, or whichever name you use is just like a temporary variables, the variables that you've just created in your loop. So and the next one you could have used, for example, for j in I, for j in I, so it could iterate. So and that yes, I don't know if you are getting it.
Yes.
Actually, I think I do here. Because if I'm getting you right, then we ought not to remove. Linda, if you can just return the outer bracket, so that the color represents the outer bracket. Then if we now for J in I means that now you go within that outer bracket, you look at what is in there. So I believe if you print it, the answer will then be different from the ones we have over here.
Yeah, Linda, can you try that?
I've returned it there. I've returned the outer and the inner. Then I add.
Then go to now for J in I now.
Now remember that when you just pass there in the print function I, it will iterate like all the elements, like the elements in the both in the first list and the second list. It will iterate everything. But if you specify, for example, index 1 or index 2, it will iterate only the elements in the first or the second list, depending on the index that you've defined there. But now when you pass this one, the I there, the print function, you can try that. Pass there J. Yeah, because now J is our new variable too. Yeah. So you can see it iterates everything. But for example, if Lorraine wanted to iterate, for example, the elements of the first, you could have defined in that part where we have I. So it means that it is iterating everything, but now you are targeting, you are only focusing on the first element. So you'll use, let's say, so one is the second one. Is the second one. So try that one. So it will iterate the Toyota. How is it?
Am I? Is it possible to remove that line that it is written there, fruits equals to blah blah blah? Because me, I'm getting even confused. After that, we're having colors. How are we having fruits? I think people are even getting confused.
I think Linda could have removed the list there at the top. You can scroll down, Linda, and then remove the list there at the top.
This
why? No. Before removing,
the same thing as this one.
Why are we removing that list at the top?
But why are we not removing the second one, the fruit one? Why are we removing the colors? We are used to defining or
need to understand.
Getting a list.
Excuse.
So by the end of the day, which is the list, the colors or the fruits?
So at the moment, you can see, like we said when we were introducing Python, we said that once you call a function, once you create a function, you have to call it. And the items that you added there at the function definition are what we call the arguments. You don't even have to delete those things.
Okay.
So so like you can see where we have that quadra something there. So that's where we have the definition of the definition of the function. So the arguments, that part where we have colors, that place we call it like the elements that you have there are called the parameters. And then now the values that you are calling with are called the argument. So that part where we have the code something there, when you are calling the fruits, so it means that you are giving the values to the variable that you've defined there, colors. So you are giving it the variables. So and the variable in that context, it was the fruits. Instead of typing the fruits there or passing the list directly in that quadras when you are calling, she used a variable so that in place of that fruit, in that part where she had to type the fruit, she added the object list. So we are not using the outer, but you can as well use the outer one. You can as well use the list that is defined outside there.
Why can they just say quadratic then inside colors and just remove the fruit list?
I think you can.
I haven't understood her question.
Let me try. Just a minute, I'll undo. It doesn't work, but I think it will do the same thing.
But
It's the
perhaps
same
maybe.
thing. It's the same thing because it's because you had already, before you define the function, you'd already given the list. So the other way around, you can do it. You can start by just defining. Then when you go through, when you get to the last part, then you write now the list, and then you call now the function. So it's the same thing. Yeah. Because it's doing the same thing. The way Nehemiah did it, we are getting the same thing. Let me just remove this one here. There's somebody who had asked, when you put one, what does it do? You see, it's doing the same thing. You can write because you've already defined the list. This function, like, it knows the list is the colors. So you call the function and the list, which is colors, it will do the same thing. And the way Nehemiah had done, it's also okay because you can decide to get away with this. Then you just define the function. Then when you come here, you do what exactly he had done. Let me just undo. No. Just a minute.
Undo again, yeah.
Yeah. So you see, it's the same thing. Now you'll get rid of this one. Or am I? It's this. I think it's the same thing.
Okay,
Yeah.
Linda.
Yes.
Then my advice would be this.
Yes.
You know, we're still learning. Things like Python, they are maybe very new to some of us. We don't even understand.
Yeah.
Let us just keep it simple. Don't
this.
Yeah, don't just keep us in that small car. Don't take us in for train. Train is very long. We won't understand. Simple for us to understand first. Then next time you can bring others, because people are seeing two lists, so they even wondering fruits.
Yeah.
They're not there. Yeah.
So
That's why you have to
means that means that if you write the list, then you go ahead and define the function. Don't go and repeat the list again. You can just. But let's go with this because this is what you've been working with from the start.
Linda.
Yes.
I think Lorraine asked a question on how you can access individual items in the second list.
We did that and we placed
one answer because it has brought. You remember what it was bringing one letter at a time.
Yeah. How about
then one inside.
Yeah. Let me do it again.
Do you mind trying a certain code?
Should be having two things.
Like this, we had gotten this way.
Okay.
Yeah, but this is not.
That is just picking the second one. Sorry, it's because when we say I in colors, it's the whole. It picks everything. So when you say for J in I, that means it still picks everything, and then it looks at what is X1 in both lists. So it picks oranges and it picks ones. That's why it's returning like this.
Yeah.
Okay, there is a way that you can.
Yeah. Okay, who is talking?
I'm sorry. Sorry. Yeah, I'm saying that there is a way that you can access a specific list. Let's say I only want to access, this is a nested list, but I want to access Toyota, Volvo, Isuzu only.
We had done that. We wrote here. We had done this.
Linda.
Yes.
For the interest, I think we can do it. So I think if the aim is not like targeting the hello.
Yes.
So if the aim is not targeting that or notation things, and I think we need a serious discussion on these loops. But for example, we can use a different cell, and then now instead of the for loops or the nested loops, we could have done what? Remember the loops can also iterate these loops can also iterate the string, the strings character by character. But now the thing here, you can try to create a variable. You can copy the previous code and then I use it in the other cell instead of typing things.
All of it.
Yeah, all of it. And then now you'll create another variable. Just after that function definition there at the bottom, you can say, for instance, or you can call it what? So you guys understand how you are accessing elements in a list. For example, let's call it, for example, the first list. Call it, for example, first underscore list. A first underscore, underscore list. And then you'll assign it to colors. You'll assign it to, colors. And then you specify the element that you want to access. So, for example, use let's say 0, and then there you don't have to use now these are many loops. You just use one loop. For example, you can remove the from the second year, remove everything there, and instead type there just print now the first, should be, you can call it for example for J in so instead of colors, use first underscore list. First underscore list. First of all, is everything okay?
I want to fix it. This okay? Yeah.
Okay.
Do you mind just modifying the first code in cell 31?
This one?
Yes, that one.
Mm-hmm.
You can write just before the definition function.
Before or after? Before.
Before.
Mm-hmm.
I think you are still accessing the list of tomatoes.
Yeah, it is.
Yeah, so can we define it first before we define the function?
So it's the
you
same
can just
thing.
copy paste the function. Okay, if it's the same thing, then you can go and you can write but I was suggesting if you can copy paste the.
So if I copy paste it, it will get rid of this one.
Okay, I think when you do back and forth things for beginners, I think it will be complicated. So what you do, let's just try to do a new cell. Then I'll explain everything in a simple way. Just do a new cell, and then let's just use simple things. Let's just use integers. So for example, let's call it a nested underscore lists. Just create a variable, call it nested underscore, for example, list, and then assign it to a nested list with the values like integers 1, 2, 3. A list, a nested, use a nested list, a list inside another list inside. Yeah, so, and then another. I want to put it in a simple way so that people can.
Yeah.
That part where we have 5, I think it will throw an error. And then you guys, I think you understand how to access particular elements inside the list. So you can call it, for example, let's call it first underscore list. First underscore list, or whichever name, yeah, underscore list. Then you assign it to the list, but you're targeting only the first element. So you'll call it, you say nested underscore list. Yeah, so that's one. Then now use just let's just do it a normal way for people to understand how the loops works even without the functions. So the next line, just do a for. Just do a for example, you can call it, yeah, that's fine. And then so there you'll do it, you'll add in that thing, colon, yeah. Then do print the print I. So you'll only access the element, it's not defined, so you have to, maybe you can copy paste. That one is lists with S, and that one is list. Yeah, for me also, I usually have issues with yeah. So I think now there, because you've defined the first list, so that should be now our variable that we are using instead of the nested list. Sorry, I was confused. It should be the first underscore list because I want to access the updated. So that part where we have for I in, instead of the nested list, we are going to use the first list because now that's our new variable. First underscore list. First underscore list, you know. So you can see now it is able to like iterate only the, you know, the it is only able to iterate what you specified. Oh yeah, it is iterating the elements of the second list. Like, yeah. So I think
These ones, 3, 5, 6, 8, 9.
people should understand how these loops works before you even go deeper into the function to use it inside the function. But if you are a beginner, if you want to understand these things better, you could go behind and understand how these loops work before you go deeper and understand how to use the loops inside the functions, you know. So basically the idea that we were trying to use with the functions like to iterate these things. I think in fact this is the best way to like explain the big O notation, you know. Like it is iterating the outer list, and after iterating also it's going to another list. For example, we specify list 1, and again it's going to like iterate the elements. For example, you can try like removing that one. You can remove that where we've defined 1. So and then I'll run so that it can print out everything, you know. Yeah, so you can see. So basically the idea of the big O notation is like trying to explain, for example, how many number of the iteration you have, or how many number of the nested. So it's going in inner levels. So that's why they square. Well, for example, when you have one nested list, it's going to be twice. That's why it is power 2. But if you have a 3, it will be power 3. So we have 2 lists inside the outer list. So that will be 3, you know, lists. That's why you'll power it like a thrice. So it's going to iterate the first one, the first list, and then it's going to iterate the inner, and then further the inner thing. Yeah. So that time that it takes, that's what is being discussed in the, you know, in the big, in the memory, that the storage things, you know. That's what is being defined in this big O notation, you know. So I think Linda, you can take it from there. And sorry so much for bringing
No
these
problem.
things, making it complicated.
Yeah, people need to understand. So in short, at some point, I can just advise you, when we are going ahead, just make sure you understand the for loops, the while loops, like those iterations, because this is the foundation. And when you get there, like you will understand how now everything is working out. Because if you don't understand it, then if somebody comes tomorrow and writes for I in something, still you'll go ahead and ask why and where and when. Yeah. But thank you so much for everybody interacting. So the next big O was so it's O, then this one was O raised to n squared. This is O raised to n raised to O raised 2 raised to n. Yeah. So for this one, power n, right?
Yes.
Yeah, thank you. So for this one, basically they say that it's known as the exponential time. So basically it denotes an algorithm whose growth doubles with each addition to the input of the dataset. And a good example of this, as they had explained in the Explore AI, is the Fibonacci numbers. And Fibonacci numbers, they are those numbers that are known as I don't know if you know the factorials. Is it the factorials?
Fibonacci is a sequence.
Yeah, sequence, sorry.
It's a sequence.
Yeah, sequence, sorry. Thank you so much. So that is an example of the O raised to 2n big O notation. So we can implement it. I'm always bad in typing. Yeah, thank you. And then, okay, so basically we define the function, which is Fibonacci, and then we place the argument, which is the number, and the number can either be 5, 10, 8. That will come when we decide to call the function. So after this, we must check if the number is less or equals to 1. So this if number is less or equals to 1, that acts like something like a base, like the base case of this. When I say base case, is that if the number is less or equals to 1, then this function will call it to return something. You can tell it to return true or to return 1 or to return anything that you want, or else the base will be stopped because it's something that we call like recursion, which we'll discuss I think tomorrow. So it's a concept that I will explain more when we get to that. So this base case means that if the number becomes less or equals to 1, then it should return 1, or you can say it should stop or something of the sort. Or else if it does not, it should return so here should return. It should return. Can you say true? Or 1, or we can say true. So no problem. Then we call the function Fiblo. I'll explain. I'm going to explain it for you, so don't worry. Just a minute. So in short, we are calling the function Fibonacci the Fibonacci. Then you say if number is less or equals to 1, this one acts as a base case. This part. This case. So the way I'd explain, if the number is less or equals to 1, like the number will be calling, like will be passing through. If it's less or equals to 1, then this base case will return 1, and it stops the recursion. But if not, it means that if the number is greater than 1, now the other argument, if the number is greater than 1, then the function will make 2 recursive calls. It will make the first recursive call where it will call the number and then -2, then the number -1. By this, it means that if you look at the Fibonacci sequence, we can argue that, or it means that it is always characterized by the fact that every number after the first 2 is the sum of the 2 preceding one. So for example, let me just, I think I can go to the whiteboard. let's just print first the result before I show you. So result is equals to Fibonacci. Then let's say we can use even 5.
Double C. Fibonacci has double C.
Oh my God. Yeah. Fibo.
What you have on top there?
I have
And symbol C. It's just for
Then correct the one on the second return.
Which one? Here.
The return Fibonacci number -2. Look at the spelling and the other ones. This one has a double C. The first, the
this
other
one.
one. That
I
one.
correct this one. Thank you so much. Yeah. So by this, it means that, let me just come here. So let's say we've called because we want to calculate don't mind, I'm using my hand to try and scribble for you so that you can see. Just a minute. Is it? No. Just a minute. I don't know why it's not writing the way it was writing in the first time. Yeah, there we go. So we have Fibonacci of 5. Oh my God, I just want to try and explain it for you. I don't know how I'll do it. I wanted to scribble something on this whiteboard. So let me try, because I don't have the pen that they usually use. Okay, but I can just explain. Let me explain from here. I wanted to make it.
Does it involve diagrams? Because I could have used
No, it doesn't. It doesn't involve diagrams. I just wanted to write so that they know how the recursion is happening. So, and why are we getting 8?
Oh, okay, sorry.
Yeah, that is what I wanted to show them. Let me try the last time. If it doesn't work, I stop. No, I think I'll just leave it there. So, in short, this is the base case. So the first thing you are trying to write the base case such that when the algorithm runs and it gets that the number we have, like this 5, you see the number is 5. If the number is equal or less than 1, it returns true. Is 5 less or equals to 1? Somebody can answer. Is 5? No. So you go. So it will not return true. It will go ahead and carry out recursion. So, and recursion, I can't explain it to you now because it's something we'll do tomorrow.
It is greater than 1.
It is less. It will be greater than 1. So it will not return true. It will return Fibonacci number -2 plus Fibonacci number -1. So that means that if the first initial call, we said the number is 5, which is greater than 1, the 2 recursive calls are made. The first one is 5 minus 2. What is 5 minus 2?
3.
You get 3. Then you come here. 5 minus 1, you get 4. So you'll end up having Fibonacci 3 and Fibonacci 3 and Fibonacci 4. You see? So you go and look at Fibonacci 3. Sorry for mentioning the name very bad. So here we have now 3. I don't know if you get it. Here we have 3, and here we have 3, and here we have 4. You see? So you go and look at 3. Is 3 less or equals to 1?
No.
If 3 is not less or equals to 1, you move ahead, and you subtract -2,
which is 1.
Exactly. Then 3 minus 1. Leave alone the 4 that we did we get 4 anyway? Yes, leave that 4
Yes.
just for a moment. So we are working with that 3. So you go ahead and you subtract to get 3 minus 2, you get 1, and 3 minus 1, you get 1. You see? So the
2.
first, you get 2. So the first 3 minus 2, you see the best case has been reached when you place here 3 minus 2. You it's less or equals to 1. So that will return 1. Then you go to the next one, now recursive call 3. I wish I had written on that. I don't know why it has refused to write, and it was writing.
I think if it doesn't,
If I write it down for you, you'll understand. Yes?
Linda, can you just go back? May I have a suggestion? You might going back to the cells. Do you know?
they use a markdown instead.
Yeah.
Because it
So
involves just writing.
I think you can just start by giving a simple definition of what Fibonacci is.
It's a sequence number.
Yeah, like someone even doesn't understand what a sequence number is. So what I'm suggesting, you can write 0, 1.
Fibonacci simply is the first
Okay, maybe.
No, 0, 1, 1. Okay, simply Fibonacci means that, for instance, if you are told a Fibonacci of 2, means you are adding the predecessors of 2, which is 0 plus 1.
Yes, yes.
Then write another 1. The result is 1.
0, 1, 1, 2.
So the next number is going to be 1 plus 1.
Which is 2.
Which is 2.
And 3.
Fibonacci of 3, 1 plus 2.
3 and 5 8.
Yeah, exactly. That's
like that.
Yeah. And that is what is happening here now.
Let me ask, Linda.
Yes.
Linda,
Yes.
you are doing the Fibonacci of 5. You say
Yes.
5 minus 2, you get 3, sindio?
Yes.
And 5 minus 1, you get 4, sindio?
Yes.
It will take the 3, then it goes again. It has, is 3 greater than, is 3 less or equals to 1? You
It's
say no.
not. So
So
you go
you
ahead.
say 3 minus 2, that
1.
is 1. Then 3 minus 1, it will be 2.
2.
So how will 8 come up? I'm still wondering how 8
Yes,
will
that's
come
why I
up.
wanted to write it down. I had simplified it down very well because I knew somebody will ask that. Question. And that's why I even prepared this whiteboard for that. Because this whiteboard will
a problem.
it needs to work because it will really help even when you are going to do those linear search, binary search, because people will want to know why 4 is moving here and going there. So I don't know what is happening.
When it swaps.
No. Yeah, I think it's working now.
Linda.
Yes.
While continuing.
Yes.
You had said when you say 3 minus 2, you get 1 in the first instance.
Yes.
That is the best case.
Yeah, it goes back to
we considering that we are adding 2.
We are adding
2, so it's 3 minus 1, then there's
so you see what will
minus 1.
You see what will happen. We are carrying out recursion. So we'll move from 5 as we go recursively. Then after the end, we'll add those numbers. When you add them together now, is when you'll get that 8. So we are trying to look
I'm not talking about I'm talking about 3.
You're talking about
3.
Base 3.
Yeah. So when you were saying from the value is 5, then we come to 3. If I could go back to the complex.
Okay, can we do it? Can we do it because I did not finish it so that you can see? Okay. So let's start. I think it's now writing. I hope it will write because I'm using my finger on the laptop. I don't have that pen that people always use on their touch laptops. So we start with 5. So we come here. We start 5 minus 2. We said we get 3. So 5, we get 3. Then the next one is 5 minus 1, you get 4. You see, now this is the initial call. Now you start moving down recursively, like one by one, whereby you go now to 5 minus 2, here is 3, then 5 minus 1 is 4. So don't look at, stop first, don't like work on these 4. Let's start with 3. Is 3 less or equals to 1? No. So you go ahead no. So you go ahead and carry, or I can write here the way, there's somebody who had suggested something for me. Let me just do this. So 5 minus 2 is equals to 3. Then 5 minus 2, no, 5 minus 1 is equals to 4. So this is the initial. So we go and start the first recursive call. The first recursive call. So we start with 3. 3 minus 1, 3 minus 2, 1, right? Then 3 minus 2. Can you help me so that I don't...
3 minus 1. 3 minus 1 is
3 minus 2. Then
3 minus 2
is 1.
Then 3 minus 1.
3 minus 1 is equal to 2.
Yeah, thank you. So you see, this is the call 1 that you've done 2 recursive calls. So you realize that recursive call 2, which is now Fibonacci, you'll go to Fibonacci 2 because the base case has been reached when you subtract 3 minus 2, which is equals to 1. So you leave this one alone, this one. Because it's 1, it will return true. You see it? So you'll go to this one, the next one. So the next one will be Fibonacci 2, these 2 here. So when you go ahead, it will be 2 minus 2.
2 minus 2 is equal to
0. And then the next one will be
2 minus 1,
which is equal to 1. You see?
So that is true. So it will terminate.
Yes, because but this one will return true. This 2 minus 1. You see? So the base case has been reached because this is 1, and also here the base case has been reached because this is 1. Okay. So we go back to which one have we not done?
4. Linda.
Yes.
Let me ask.
Yes.
2 minus 2 is 0.
Yes.
Right? So that is not true, because if you look, there is if number less than or equal to 1. So that one does not work there. 2 minus 2.
It will work.
Yeah, okay.
It is less. It is less than 0.
Yes.
It is less. Yani, it should include 1. It should include 1 and any number that is less than 1.
Yes.
Yeah, because she had not mentioned that. That's why I was wondering.
Oh.
Okay. Who else is stuck? Like, who is wondering what is happening? Who else is stuck? Nobody? Okay, so nobody.
See how that 8 comes up.
So please proceed.
We are going to get where the 8 is coming from because the way this, who had explained the way the sequence numbers follow each other, you'll see it will start following each other that way. If you are keen, because already we have 0 and we have 1, 1, you see? Then 1, 1, 2. Are you seeing what is happening?
Yes.
Yeah.
Who is stuck? Please let nobody be behind. Like, that is what this algorithm is trying to do. I'm just showing you what it's trying to do. I've even shocked. I've only taught big O, and there is a lot to work on. I'm even shocked. Nehemiah usually see what. Yeah.
I think algorithms have shown us that.
Yes.
So I think we are here for a while. For me, binary has shown me that I'm not where I've understood the difference between like narrative and the other one.
You will understand. In Jesus' name.
So, Linda, are you through or you are still?
Amen.
I'm not through because we have reached here and we picked the 3 one and we went 3, then we picked 3. So we go back to 4 now because this one has reached as satisfied.
Okay, fine.
Yes, so you go to now 4. You start 4 minus 2.
2.
Then
4 minus 1.
3.
Minus 1. 3. We have not reached. One of them reached the cat.
Pardon?
One of them have reached the cat.
I can't hear you.
You see?
Yes.
Oh, none of them have read they won't return true.
Yes, these ones won't.
Greater than 1.
Yes, they won't return. They won't return true. But remember, the result is already known from the previously for the Fibonacci of 2. What is because we have the Fibonacci of 2? We already have it here. Is it this one? Because we got to somewhere, and the Fibonacci of 3. We have already done it because we stopped here and we went 3 until we narrowed down, and we have the Fibonacci of 2 already. So we need to.
Yes.
Is it to? We need to do just a minute. So the Fibonacci of 5. Just a minute. Yeah, because we already know the result of it. This was the initial call. Then we already know the recursive call for 3. We already know the recursive call for 2, and if you minus 4 minus 2 and you minus 4 minus 1, you see you're getting 2 and 3. If you go ahead and say 2 minus 2 and again you go ahead and say 3 minus 1, so you see you are repeating yourself because you've already done it here and you've already done it here. So our goal is to make sure we sum the we need to sum the recursive calls, all the recursive calls that you've done. So the first recursive call was the Fibonacci 1. And what was our Fibonacci 1? Our Fibonacci 1 is the one we got when we reached the base, which is this one. You see, that was our Fibonacci 1. So that is the first one that we got Fibonacci 1. Then you go to the second one, which is Fibonacci 2, and Fibonacci 2 here is the call number 3, which comes here after we said 3 minus 1. We got 2. I don't know if you are getting it, or are you lost?
I think I'm lost.
Where?
On the it's called what Fibonacci thing. Like how are you like doing those repetitive things?
So let's say this is Fibonacci. This is the initial call. Let me do this. This is the initial call, which is Fibonacci 5. That was the initial. Everybody's there. Then we went on the first call, which the first call we did on Fibonacci. What number did we do the recursion on? Yeah, we did on 3. Do you remember? 3. So that is 3. You remember where we got this one is 3 is greater than 1. Then we got one of them is adhering to the rule because it's less or equals to 1. Then we went ahead because we had remained with the 2 and 2 is greater than 1. We did Fibonacci 2. You see, for this one now, this one was done for this. 5 is this one. Then 3 comes here, and then 2 comes here. I don't know if you are seeing it.
So that to just see if maybe I've understood.
Yes.
Like you did 5 minus 2, it gave you 3, right?
Exactly.
And
I'm doing it because it's here on the. We wanted to return that. We wanted to return the sequence.
Okay, and then when you go down there, you you did 5 minus 1 is equals to 4, right? As the second one.
Yes.
And then now you took 3, the first 3, as your first Fibonacci.
Fibonacci, yes.
Right?
Yes.
And then you did 3 minus 2.
Exactly.
To give you 1.
Yes.
So it ended at that.
Yes.
Because you cannot do 1 minus 2.
Yes.
In a layman's language, or in a layman's understanding, the way I'm understanding it.
Yes.
So it ended at that, and then now you had to pick the 2 because 2 did not meet that less than or equal to 1.
Yes.
So that you did 2 minus 2 and then 2 minus 1, and then it ended at that.
Yes.
And then after that, for these 4 minus 2, you went back and picked the second 4.
Yes.
From 5 minus 1.
Exactly. So we jump now, we go to the next. And remember here, when we went for the Fibonacci 3, one of them gave us 2, and this 2 is the one that is leading us to the next. And remember the other one gave us 1. You remember? So that you can even call it Fibonacci 1. And this one returned true, maybe to make it easier for the first iteration, isn't it? Then for the next one, we came here, we got Fibonacci 2. Under Fibonacci 2, we realized that 2 minus 2 is 0. Then 2 minus 1 is 1. So you have Fibonacci. Under here, you have Fibonacci 0. And Fibonacci 0 is like you've reached also the case. See, that is true.
Yeah.
Are we together?
Yes.
And also under this Fibonacci 2, we also got the Fibonacci 1 that you subtracted, which is also
1.
true because it reached the case. Is it okay up to there?
Yes. So
yes.
So this one is satisfied, this one is satisfied. Yeah.
So the question is,
yes.
So for the recursive algorithm, you're working through until you reach the best case, and now you come and pick the next one, then you work it through until you reach the best case.
Yes. And now when that recursion now comes in, because we have how many parts are true? We got under 3, we got Fibonacci 1, which is true, and we got Fibonacci 2. And we had this Fibonacci 2. So we need to sum Fibonacci 1 plus Fibonacci 2. Which are these? These and where is the other one, Fibonacci 2? And this one. I don't know if you get it. Are you getting it?
Linda, what are we summing? We are summing 2 plus 1.
We are summing Fibonacci, yes, because we have Fibonacci 0 and we have Fibonacci 1.
2 and 1.
Let's go under Fibonacci 2 here. Right? And we are here.
Okay, yes.
I want you to look at here. So when you sum Fibonacci 1 and Fibonacci 2, you'll get 1 plus 2, which is equals to 3. Yeah. Then if you go to Fibonacci 2, not 2, is it 2? No, 3. If you go to Fibonacci 3 is the one that will be 1 plus 2. Then because it brought 1 which returned true, and you went ahead and looked for Fibonacci 2, then you add 1 plus 2. So you add Fibonacci 1 plus Fibonacci 2.
To give you Fibonacci 3.
Yes, to give you 3. Yes.
Okay.
Because that is what comes in when you do a recursion on Fibonacci 3. You get 2 and 1. Then for Fibonacci 2, where is 2? You get
1.
Yeah, you get 1.
Because you have 1 plus 0.
Yes.
Okay.
So after that, we'll move ahead now to the next one. Now the one you left here above. So you do the same thing. You say 4 minus 2, 2. 4 minus 1, 1. So you realize 4 minus 1 is 3, 4 minus 2 is 2. And you remember you got already Fibonacci 2, and you've already gotten Fibonacci 3. You see? What is our you have Fibonacci.
The upper one was already 4,
yes.
And then you add with 4.
Yes.
Okay.
So Linda, let me ask.
Yes.
So like when you do this, the end result is supposed to be 1, 2, 1, 0, and because
yes,
and because they say you come and repeat the same thing, it is just going to be you'll add 1, 2, 0, 1, 2, 0, 1, then 1, 2, 0, 1, then so that it adds up to 8. Sindio?
Yes.
Oh, got it.
So it's like it's repeating itself, it's recursive. It's calling itself. A recursion, it means it's calling itself. It's calling itself as it moves. So you'll end up getting 8.
Oh,
Thank you. Yeah.
Now,
Now,
thank you so much.
So I think if somebody has not understood, you can text me. If you want to understand it better, you can just look for me tomorrow, maybe during the day if you are free. My name in the group is Tianka, so you can just call me, and then we can Google Meet with you, and then I show you step by step, so that I think we can move on.
Ignatius is saying you explain to him in Kiswahili.
Yes.
I have a question. We are trying to look at the Fibonacci of 5. I hope I'm not trying to confuse anyone.
Yes, yes.
Simply when you say that you are trying to get the Fibonacci of 5, we simply mean that we are trying to get the 5th element in that particular series.
Yes.
So if indeed you are trying to find the 5th element in a particular series, do you mind scrolling up a bit?
Here.
Oh, yeah. So what will be the series? Which series are we looking at?
It will. Okay, who is talking? You can answer him.
So
let me answer you, Nathan.
If we are saying that the number is less than or equal to 1, we can try to do it physically and see.
The thing is data matador. Your data. The Fibonacci sequence, it's a particular type of sequence. She has not come up with these numbers.
Yes.
You understand? You see, when we say a sequence, tunanzanga, like you can say a sequential order, like 1, 2, 3, 4, 5. That is a sequence the way it is set. Fibonacci is a specific type of sequence where it is a sum of 2 preceding numbers. So if the first number is 1, the second number will be 0. It will be 0 plus 1. The third number will be 1 plus 1, which is 2. It is set in a particular way. It's not that numbers that she has come up with. It is just a sequence that has been identified. You understand?
I think Nemo. To put it clear, perhaps who is called Linda, you can try to change, for example, the spelling for Fibonacci there and the function definition, and also
it looks bad. It's
no, I'm just trying to explain something.
So I do this.
Yeah, so to be like it's not a fixed number, it's something that we've defined there for recursion. That's why you can try to run.
Also
try to run it and see if we'll get the same output.
Like the way it is, should I change the spellings here and here again?
In fact, by they do this, just use any other random name other than Fibonacci.
Okay.
No, don't delete. Just
okay. Here.
Yes. Or you want to use a different cell? Or...
Yeah, I wanted to use a different cell. Maybe if somebody wanted the.
Don't use a list, because a list is a defined method in Python.
Okay. I can use maybe.
Use chicken. Yes, chicken. And then So the idea of this recursion, and I think we need to begin from the recursion part,
Yeah,
so
it's
that people
the
understand.
next part.
I remember it is case sensitive Python. Remember that.
Oh my God, you people, we have our notes.
Yeah, so you can see it's not like a predefined something you have to implement. That's when the recursion can occur. It's not like I heard the way Nemo was explaining, it's like something that is predefined. You have to write a program and that does the the recursion, the recursion that will implement that Fibonacci. So basically, I think the best way for beginners to understand, I think we could go back and understand what are the recursion functions in Python, and then after that, then we can go deep and discuss these Fibonacci, because I don't think if we use that approach, the beginners will understand.
Yeah,
So
and
that Fibonacci thing is not like a it's not like a predefined thing that will automatically. You have to implement. You have to write a program that will do that. And that Fibonacci thing. But now the idea is like that when you are implementing that Fibonacci thing, is when you are implementing or you're working on the that big O notation that has a syntax of O, 2 power power
n.
Yeah, power n. So I think also then and then after that, I think we can try also implementing using these building modules, or maybe different modules, to calculate, to see the real scenario, or the real output time taken to execute something, so that people can compare and see the difference in and the time it takes, and and all that. So I think maybe to begin in a better way is to go first of all and understand first of all recursion, for people to understand. That's just my thinking. That's just my thinking. I'm trying to put my shoes in a beginner perspective. I'm trying to be like a beginner. I want to understand these things very well. So I'm trying I don't know how to put it, but basically for a beginner, I think it's a good idea, to understand the basics as you advance on things to do with the recursion. Recursion basically is a way on which a function can call itself. I don't want to touch on that.
Yeah, I think it's the next topic. Hello, it's here, and
So a question.
We'll do them.
Hello.
Yes.
I'm wondering when we're using this recursive algorithm, what we're trying to generate is iterable that is Fibonacci 5. And why is it H5? Why is it 8 instead?
Why is it
8? Because if we do the sequence 0, 1, 2, 3, 4, 5, item at Fibonacci 5 is 5.
It's actually exactly PG. It's actually 3.
It is not 8. It's 5. It's not 8.
Yeah, it's actually
you start
3.
with 0. You start with 0. 0, 1, 2, 3, 4, 5.
No, you exclude actually 0. You start with 1.
No. I'm saying I was reading it as reading. Okay, I was reading it starting with 0, but it's okay. I can start with 1. If I start with 1, then I read from 1. 1, 2, 3, 4, 5. I thought Fibonacci starts from 0.
But what is the?
So I thought it was number 5 and not 8.
And what was the Fibonacci of 0?
Okay, I'm actually getting what PG is saying, because I was also thinking the same. If we are indeed talking about Fibonacci, logically it's mathematics. It's just like 1.
Yes, it's math. Yes.
Yeah. For instance, in our algorithm here, we are saying that if number is less than or equal to 1, it will return true. But then our number is 5, which means we continue with this particular algorithm.
Yes.
So if practically we are saying that, okay, if you want to get the 5th element, basically, if you want to get the Fibonacci of 5, we actually want to get the fifth element in that particular sequence.
Yes.
And if you do it practically, you get that the fifth element is going to be 3.
It will be 8. You're not going to get you should not get the fifth element. You should return the sum of the fourth and fifth element. Do you remember when the first person was saying 1 plus 1 2, 1 plus 2 3, then 2 plus 3 5, then 5 plus 3 plus 5 8. So it will return 8.
So ideally, you're saying that the first element is because if you're talking about the fifth element, I was actually the one who was saying like you could write numbers from 0. 0 plus 1 is 1, something like that. So the first element is good. So are you saying like the first element is going to be 1, not 0?
No. Yes.
Are you sure?
The first
element is 1 because we've said it will return 1. Because if the number is 0 or if you get the number is less or equals to 1, you equate it to 1. We had said 1 or we had said true. We had said return 1 or it's true. So that means it becomes 1.
And then maybe the other thing about setting the
So
base.
0, 1 or 1 is this. I'm not even sure what I'm saying.
I thought, okay, from my understanding is that, let's say we have the number is 1. If our number is 1,
okay, we can do it.
We are saying that if the number is less than or equal to 1, we are not going to continue with the particular, because it will not carry out the rest of the code, isn't it?
Yeah, so it goes ahead.
But now our number is 5. We want the fifth element, which is greater than 1. So it means it's going to continue through the particular code.
Yes.
So if you want the fifth element, I don't understand why you're saying that we're going to start from 1 if we are trying to look at the Fibonacci of 5. Like, that's why I was asking, which sequence are we looking at? Because I thought Fibonacci is...
Let me ask you something, Data. If the number, it starts with 0, you see when you start with 0, it can't continue. Do you understand that? Hello?
If it starts with 0...
Yes, I'm saying if we start with the first, let us say the first number is 0. You see it can't continue, and we are saying Fibonacci is a combination of the first and the second element. Sindio? Of 2 elements. Ama mimi ndo sijaelewa.
Like if you are saying Fibonacci of 5, we want to get the fifth element in a series. And in my opinion, our series starts from 0. 0, the next number is 1. So the preceding number is going to be 0 plus 1, which is 1.
1.
So if you want to get the third element in that particular sequence, is 1. Since 0 plus 1 is 1.
The third element is 2.
Okay, let's do it again.
Yes, that's you're right, actually.
It can't because okay.
Starts with 0, 1, then 0 plus 1.
Just a minute. Is it data?
No, you can call me Ian. You can call me Ian.
Okay, sorry, Ian. Sorry. Can you give me your sequence? So you said 0 and then?
0, 1, 1. So 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. So our Fibonacci, our fifth element, Fibonacci of 5, when you say Fibonacci of 5, we are simply trying to say the fifth element in that particular series.
No.
So our Fibonacci of 5 is 3.
And if it could be 3, then our algorithm could have given 3 here. It could have not be given 8.
So Linda.
Yes.
Can I come in on that?
Exactly.
Just maybe to see if there's something I'm understanding.
Yes.
Whatever Ian is saying, when you check it, because I've been trying to look at that on my side. Okay, if you just like say the Fibonacci of 5, that is okay. Okay.
Yes.
But now, what we need to look at? We need to look at our code. What is our code really trying to look at? Yeah, because there's this return thing here, whereby it's saying return and then number minus 2 plus number minus 1. So that is a consideration that we need to look at.
Yes.
Because at the end of the day, when we are making all that calculation, there's a relationship. Although I'm not conversant about the thing, but what I'm trying to look at, there's a relationship between Fibonacci 5 and then number minus 2 and number minus 1. And that is why we were making that calculation to just make it simple to understand why we got the 8.
Yeah.
Yeah, because I would maybe suggest someone to just copy that and maybe try to look at the same like code in any search engine. Maybe you can, maybe you can search it and then maybe see if like the search engine will give you the same, because I don't think it will give something far different from this. But exactly what you are saying, if you are just only looking for Fibonacci 5 only, that is correct. The way you are explaining, but it has something that we need to look at. This return code here.
Exactly, you're right. We are not looking at Fibonacci 5. We are looking at this. It should return this number minus 2 plus number minus 1, and that's why it's ending up to be 8.
Please look at the code. There is a code that Simon had written. I've also tried to run it. It's on the chart.
Maybe Simon can explain to us. His hand has been up for some time now.
Because I think the only difference was what we were returning, because there we were either returning 1 or returning true, but in his we are returning n, which is the number we are defining there under Fibonacci. So when you run that, you get 5. It's because it's returning n, so it just returns the Fibonacci 5, so it just returns the 5 inside there. That's why maybe it doesn't even run it through the, what is it called? The if statement. That's what I want to understand.
Is this the code we are talking about?
Yes. I think I have gotten why it's returning 5. Actually, I think so. You see where he's saying return n, and then we came and said result equals to fib, then 5. So we have already replaced what we defined over there as n with 5. So it will just print 5. It won't print any other number. So like if we say result equals fib 6, I expect it would print 6.
Yeah, that's hard coded.
Yeah, that's where the problem was. Yes.
I have a question.
Can you just repeat exactly what you said? On this second one, the reason why it's bringing that 5, where is the hard code, like the 5? That is making it to like return the 5. That's just
explain?
Yeah.
Wait a minute. Can someone do that? There's something that is
Wait,
here.
actually it's not hard coded. Ebu try putting 6. 6 will return 8.
Yeah.
Yeah. If you put 6, it will return 8. Yeah. So I know it's not hard coded. I don't think it's hard coded. So I want to understand why his result, like, because he's saying he's returning n, which is what we defined on top there.
Yeah.
But for us, we were returning true or something else. So what is the difference though?
Excuse, I have a question. What exactly are we adding? Because you were saying that there were some elements that were supposed to be added, like 0, 1. So I'm asking, what exactly is being added? because I think that's where the 8 and the 5 are differing.
Or in the return, he had put n instead of 1. In our sheet,
If you put
Guys, despite me being in a matatu, I can help.
If you put
So
n,
with the Fibonacci series, it's just 0, 1, 1, 3, 5, whatever, right?
Yes.
But now here we are doing the recursive thingy that return fib n minus 1 and fib n minus 2. So when you get Fibonacci 5, right, on the series, you'll just count 0. You ignore the 0 normally. You start 1, 1, 2, 3, 5, 8 or something. But here we are doing n minus 1. 5 minus 1 is 4. So the fourth number in the Fibonacci series is 3, right? And the 5 minus 2 is 3. So those are the numbers in the Fibonacci series, which is 3 plus 5, you get the 8.
That's like a shortcut. Wow.
Where?
Can you, Linda?
Yes.
Can I make this request? Can you do the Fibonacci thing without the recursion thing, without the function?
Without
then, without the Python thing, without the recursion, just do the Fibonacci, just manual calculation. People understand how it's done, and then I shall try again with the Python way, with the recursion way. Just try like show maybe which numbers are we adding to get what, and then what to get what. Just normal way, and then once people understand that way, then we shall go to understand how it is being implemented in the code way.
Yes, without the recursion, Fibonacci 5 is
You
fine.
can
It's
create
the
a
fifth
markdown.
number,
Yes,
just
yes.
that. But when you do the recursion, hapo ndo mali hiyo confusion inaanza. Do it the way the Maya is saying. I think people will get it.
So like how do I write an algorithm, or what do you mean?
Just try to like explain how Fibonacci. You say that Fibonacci is what? The definition of the Fibonacci. So like you try to get the values or the Fibonacci of 5, just without the code things. Just doing it manually, how you add in which number and what, and the summation to get what, to get those things. And then we shall when we understand it that way, then when you go to the code, people will be able to understand like what the function is doing.
Okay. So I don't know if let me just try. I'm not sure. So let's define.
Actually, not defining things. Just explaining to like for example, someone can maybe try to explain or define the definition of the Fibonacci.
Okay. Who will do it?
Yeah. So Linda, you see, Fibonacci is just a series, right? It's 0, 1, 1, 2, 3. People have gotten that.
Yes.
So when I'm just saying what is Fibonacci 5, I start from 1, 1, 2, 3, 5. So Fibonacci 5 is 5. But now here what we're doing, we've finished the Fibonacci, right? Now we're doing the recursion.
Exactly.
So we will explain your recursion.
It's calling itself.
Because it's a lot of noise here.
So I think the only thing I can say, it's because we will stay here forever and it's 11:12. Let's do this. I don't know if even my schedule is now interrupted because today I was to teach until quick sort, but we are still on big O. That means we haven't touched searching, we haven't touched sorting. So I think let's do this because recursion is the next topic. Keep in mind that we'll go and do recursion, then we'll come and check how now this came in. I think now that will work because we can see we'll be here for the next even 1 hour. I think if that is a good
Linda,
yes?
don't worry.
Linda.
Yes.
Can I come in, please?
Yes.
Please go back to that notes and let's do something.
Yes.
Let's write out the series of the Fibonacci and the index of that Fibonacci. Put it on top of each other so that people can use compare and so that our language can be clearer.
Okay, give me what I need to write.
Okay, so a list of the first Fibonacci, which
Yeah.
is let's start with the index first. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
I write like this.
Just a square bracket. Just in bracket here. 1, 1, 2. 1, 1, 2, 3, 5, 8, 13, 21, 34.
You can stop there.
Yeah. So on top of it, just on top of it, let's now put 1, 2, 3, 4, 5. Let's start on the same. Maybe yeah. Go ahead. You clear this the list equals to so that everything will align.
I put what? I put another list.
No. Okay. Yeah. Don't write out numbers. 1, 2, 3, 4, 5, 7, 8, 10. Yes.
Like this.
Sorry. Just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like that.
Yes. So on that second list, remove the list and equal to. Yeah. So the lower list now is the Fibonacci.
Yes.
The first Fibonacci number is not 0, Abi. Is 1. Okay. So now, if we now say the fifth Fibonacci 5 is the fifth element. So Fibonacci 5 is like starting from. So let's remove that first one. Let's put dash. That number 1 on top. Just put dash. Just clear it out. Yes. You just clear that number and put the space bar.
Like that.
Remove the number 1 and put the space instead.
I remove number 1 and put space.
Yes.
Like that.
So exactly like that. So type the space bar again, please.
Pardon?
Tap the space bar again. Space bar. Yes, right there. So if we want to say that the Fibonacci 3 is the number 1 under that Fibonacci under the third element. Fibonacci 5 now. If you now count, what's Fibonacci 5 is number 1, 2, 3, 4, 5. Fibonacci 5 is the 6th number on that line.
Can I?
Go ahead.
I think the thing here, people need to understand what is this Fibonacci thing very well. Someone said that it's a series of number or a sequence of number. That's not the case. It's not just a sequence of number. We can say a sequence, but it doesn't follow each other. Like each preceding number should should sum up to the next number. So it means that there are some numbers that doesn't have the Fibonacci thing. Like you can use a different cell, for example, the cell. Let's just make it simpler. So like a 1 is Fibonacci of 1 is just 1, right? And then now Fibonacci of 2, we have a Fibonacci of 2, so we'll have 2 plus 1 plus 1, then it will be 2, right? So, and then for what? For 3, it will be 1 plus 2. It will be like 2 plus 1. 2 plus 1, then you get 3, right?
Yes.
And then now, for 4, because these preceding numbers should sum up to the next, so it means that a 4 doesn't have, right? We will only have 1 plus 2 that is how can I put it? So you sum up with the preceding value. So the preceding value, for example, for 2, it will be 3 plus 2. That will be 5. So it means that we don't have 4. We don't have 4. I don't know if you are putting. You can just do it at
Yes,
least.
yes. So
Don't
next line will be 5 equals
don't
to.
do the summation thing.
So it will be?
Just you can use just a list, just a number.
So
I
like
think it will
this.
be clear. Yeah, you can clear everything. In fact, let's just clear everything so that it can be quite easier. So the first one is 1, right? And then now 2. So the second one will be 2. 1 plus 1, it will be 2. So the next one you'll take that 2 plus 2 plus 1. That will be 3. So the next one it will be, we say 2 preceding values. So it will be 3 plus 2. Yeah, that's 5. So the next one it will be 5 plus 3. We said 2 preceding values. So it will be 8. So the next one it will be 8 plus 5. It will
Nehemiah.
be 13. Yes.
Sorry for cutting you short. Ideally, we should start with 0. The first sequences of Fibonacci is usually 0 and 1.
Yes. Yeah, sure.
So it's nice to start with 0 so that people can easily understand.
Yeah, so that's how it is. So like a 1 plus 0 is the same. That's why I ignored. It's just the same as 1, but it can begin like from 0. So it adds like a 2 preceding values. When you sum it, is what it will give you the next like item element. I don't know.
Sorry once again. So after 1, it should be 1. 0 plus 1 is 1.
0, 1, 1, 2.
Yeah, so before 2 is another 1.
Oh yeah, sure. Yeah, that's why 0 plus 1. Yeah, sure. You have to add in 1.
Let me just ask Dr. something. 1 minute, Nehemiah.
Yes.
See, we have said that if the number is less than equal to 1, it should just return 1. So it means that it will not undergo the Fibonacci sequence.
So in this context, we are assuming that we don't know anything about the recursion things. We are just trying to understand what Fibonacci thing is. So that's why I was trying to explain. Someone said that it's just a sequence of numbers, but it sums with the 2 preceding values. That's what it will determine the next value. So I think first of all, people had to understand what Fibonacci usually do, so that when we do the function way, people will get it much better. Otherwise, I think also time is much gone. People, I don't know if they understood, but I think we can prepare so that we can discuss these things maybe in details for people to grasp. But I think at the moment,
sorry for interrupting. That part for what we return in the first conditional statement. When we return 1, it brings 8. When we return n, because n is what we defined up there, it brings 5. Why are we returning 1 or 2 and not n?
I'm trying to look at some of the codes on Google and they are returning n. So I want to understand, why are we returning 2 or 1 and not n, which is what we define?
Let me try something.
Can you repeat the question, perhaps? This n is it's not just anything.
Yeah.
This n should be like.
How about if you say return number?
Return number. Okay. Yeah. That's a good idea.
Our number will bring.
Because you know why it will return the number. Do you know why it's returning the number? That is the argument you've defined in the function. That is the argument. Why are you returning it? Because you are returning the argument that you've called in your function. So that means if you place here, if you say fib 5, it means you are calling this, if you are returning n, that means you are returning these arguments that you have called in the function that you defined. That's why it's returning 5. But if you return 1, that means anytime you have the number less or equals to 1, you are returning 1, because this is something like a base case. A base case is something like, if you are carrying out a base case, it's something like you have a box. Or that example that was on Explore AI, you are playing a video. A video is playing, it's playing. So it starts from 20 seconds, 19 seconds, like that. When it comes and reaches 000, it stops, because that is the base case of that algorithm. So the person is returning n. I think this algorithm is understanding n as this n that you called in the defined function. Yeah.
Linda,
C will give the next number in the Fibonacci sequence.
we have a condition, and our condition is if the number is less than or equal to 1, it's going to return the number itself.
1.
Exactly, but now it doesn't meet this condition.
But now if you put 1,
actually say just type else, then you run it, we see what it will return. Else,
Okay, put another number.
Just a minute.
Because it should be 5.
Okay, Jolene.
When I say something.
Pardon. Just a minute. Just a minute. Everybody mute. Who was talking the first? Who was the person talking before Jolene talked?
I was saying.
Then after Ian, we'll go to Jolene. After Jolene, we'll go to, is it Kito? Kito, then PG, you'll talk after Kito. So can Ian do it? Ian, can you say what you are saying?
Yeah, I was saying, maybe we just go back to that code. Yes, thank you. You see, by the way, we are getting Fibonacci of 5. Okay, let me first start what I had said previously. You know, if we put there a number, return number, remember we have a condition. You know, we start executing a condition from the first part where we have a define. Then, I mean, the condition starts from if. If the number is less than or equal to 5, or equal to 1, sorry, return the number. So if our condition is met in our second line of code, where our condition starts, it will return the number. I don't know whether you are getting me. It will return the number. Okay. If the number, let's say if a number like 0, we can even, let's say a number like 0, it will return the number 0 if the number satisfies the first line of code. So I don't understand when you say return 1. But if we say that, another thing is that we are getting a Fibonacci value of 5 because we've said if the number is less than or equal to 1. I think you can also try and say if the number is less than or equal to 0 and see what happens.
Then return?
If the number is greater than or equal to 0.
Then I return?
You can even say a return number or even 1 doesn't, and see how.
It's 5.
Oh, it's 5. Yeah, but ideally what I'm trying to say is if the number that we are trying to call is satisfies the first condition, it will not execute the remaining line of codes. That's what I think. But I would really like to understand why you are saying return 1. Maybe.
Can I help Linda to answer? Okay.
Yes. After you've answered, I think we'll go to Jolene, then Kito, then PG, then the person is raising the hand will follow after PG has talked. Make sure you all talk. Okay. Nehemiah, go on.
So basically the essence, by the I think people should understand where this first condition is coming from. Like if you are doing the Python way, there's something that we called Stack Overflow. So like it can go all the way to the negative numbers. So you need to set a base statement so that you may avoid avoid that thing that will go to infinity until it interfere with your system, the memory of the system. So for instance, when you say like for example, you set this the base like in this context it can be like the starting like a value, or maybe the last the like at the first, let me say it like at the first option. And then now so when you say when it reaches 0, other than continuing to infinity, you are going to return something else so that it may improve performance of your computer. So the return option here can be anything, can be literally anything, you can return anything. You can say an integer, you can return maybe a string, you can just say anything. But now the other thing that I think you need to correct, Linda, before the
Yes.
other return, you need
Yes.
to, for a good practice, you could have added there the else if this condition is not met, and then you can say, for example, else do something else. Yes.
Else.
Yes. So else,
Yeah.
else, and then a colon. Then that return statement should be after that nini. Yes. Yeah, so basically that part where we have the number Ian, it can be anything. Even one can work, and something else can can work. It's just anything that you want to output or to print in the terminal so that people can see that the condition is met.
Nehemiah,
Yes.
there's somebody. Simon wanted to explain something. His hand has been up, I think, for the last 15 minutes.
Oh,
He's
sure,
been
sure.
wanting to explain about this Fibonacci
He's actually
sequence.
the one that came up with this return n.
Yes.
Maybe we give him a chance before we all
Sure.
talk.
Yeah.
Yes.
Simon.
Guys, let me just contradict Nehemiah a little bit when you continue. Kindly. Because you see what you are doing, what you guys are doing here, you are using the recursion method to get the Fibonacci series. Sasa hii 0 1 1 5 3 5 sijui nini, kama hauijui, you use the recursion method n less than or equal to 1. Haiwezi kakuwa hapo 0, lazima ikuwe
Jolene, I
less than or
suggest
equal.
that you can stick in English because you have
Okay, sorry. So the recursion to generate the Fibonacci series using Python programming language, you use the recursion method, right? The recursion method is if n is less than or equal to 1, not 0, it has to be n less than or equal to 1, you return n, else return fib is n minus 1 plus fib n minus 2. That's how you get now the Fibonacci series. So if you say fib 5, like the first time we were saying, the answer should be 5. Like the answer should be the 5th number in that series. Okay, and that's what I want Linda to do, to return the way the code was, so that you got 8, to correct your code, because now that code is wrong. You are using the recursion method to get the Fibonacci series. In this case, you are someone who doesn't know how the Fibonacci series looks like. Okay?
Maybe just to clarify on that.
Return n.
Maybe to
Else
clarify.
return that. Then you say you see.
Okay, maybe to clarify, I wasn't like trying to explain Fibonacci thing. I was trying to explain that part where Ian was talking about the return statement. And
Okay.
that part
But
I wasn't talking about the Fibonacci. I was talking about why you need to have that first condition and yes.
Nehemiah, and why is it that it was giving us 8?
Because you are returning 1 or 2 instead of n.
Okay. Yeah, let Simon talk. Simon, can you talk? Kindly where you are. Can you talk so that maybe I think you can help us?
Can you hear me? Can you hear me?
Yes.
Okay, so let's take a simple example, Fibonacci of 3. In this case, our n is equals to 3. It comes to the if condition. If n is less than or equals to 1, return n, but 3 is not less than 1. True. So it goes to the next part of the else. So return, what has happened to the code? Okay, return Fibonacci of n minus 1 plus Fibonacci of n minus 2. So in this case, it will return Fibonacci of 3 minus 1, which is 2, plus Fibonacci of n, which is 3 minus 2, which is 1. So we have return Fibonacci of 2 plus Fibonacci of 1.
So itakuwa 3.
So wait, the second part is Fibonacci of 1. It goes back and checks and sees that n is equals to 1 and n is less than or equals to 1. So it returns n. So for the second part, we'll have plus 1. Are we together? So our return statement now reads Fibonacci of 2 plus 1. So now we are remaining with the first part. Fibonacci of 2, it goes and checks. 2 is not less than 1. So it goes to the return. So it comes and does Fibonacci of n minus 1, which is 2 minus 1. We get Fibonacci of 1 plus Fibonacci of n minus 2, which is 2 minus 2, and it's 0. So again, for the second part, 0 is less than 1. So it returns n, so 0. So now our Fibonacci reads Fibonacci of 1 plus 0 plus 1. The last part is Fibonacci of 1. It goes and checks and finds that 1 is equals to 1 and it returns 1. So we have 1 plus 0 plus 1. It returns 2. That's how it works. Are we together?
Yes.
So basically,
I think you should instruct Linda to write.
Okay, I know what he's saying.
Okay.
So can you talk? I know what you're saying. So you said we are working at fib of 3. So we look at if 3 is less or equals to 1. Then we notice it's not. Right? So that means we go to the next now part, which is the return. If it's less or not equal to 3, we go ahead and now do this return part, which is the recursion. So that means we have fib, then we have 3 minus 1, then plus fib, then 3 minus 2, right? So we end up with fib 2 plus fib 1, right? So you come and you go next to check what is fib of 1. You go back. Is 1 less or equals to 1? Yes. That is what you are saying. So this one turn becomes 1. So that means we will be having, so from there we'll be having fib 2, then plus 1, right? Then we go ahead. We go now to fib 2 because this one we've already gotten it. So we go to fib 2. Fib 2 we go back. Is 2 less or equals to 1? No. So you go to the next part, which is recursion. So that will be fib. That will be fib 2 minus 1 plus fib 2 minus 2, then plus fib 1.
Minus 2.
Plus 1.
Not minus.
Right. Yeah. Thank you.
Inside the second bracket should be minus 2.
Minus 2. Thank you so much. Okay, so we are there. So we come and get fib 1, then plus fib 1, then no, not 1 0, then plus 1, right? Then we come, the fib of 1 is 1 less or equals to 1. Yes, so it will return that one that we said of the end. So there will be 1, then plus fib 0. You said 0 is less. Is it less or equals to 1? Yes.
Yes.
So it will be 1. Then, so the answer becomes 3. Is that what you said?
No, fib 0, 0
Yes.
Is equal to 0.
Okay, so this is 0. Okay.
So you get 2.
2.
You get 2, which is fib 3.
Which is? Yeah,
3.
2, yeah.
So basically you have to, with recursive, you have to go until the base case. The base case is our exit strategy.
Yeah.
Move until you get
So why is it that for 5 you are getting 8? That's the mistake, because for 5 you got the 5th number there.
Yeah, the 5th number is 5, not 8.
But for me, I was looking like if we
try that with 5.
But Jolene, in Python, we said the number has to be n, either n less what n should be less or equal to 1. So if it takes 0, if it starts with 0, it won't do. It will be 0. If it checks 1, it will be 1. It will not continue.
Yeah. Even the Fibonacci don't start with 1.
Yeah, that's what we have done.
We start with 1. We are starting with 1. It makes sense. Even if you do this method using 5, Python is just doing whatever she has done behind the scenes and giving you that. And that whatever she's doing is what is the recursive.
Yes.
Count 1, 1, 2, 3, 5. It will be
5.
The 6th number will be 8. The 7th will be 13. The 8th will be 24. That way, the Fibonacci, like you are generating the Fibonacci series. That's what I'm saying. It's like someone you don't know what a Fibonacci series is, so you are using this method to generate the Fibonacci series.
Okay, is everyone now confident? And I don't know, there's a person raising their hand, Anthony and John. Can you say something? Anthony, can you talk, please?
Okay, I think essentially what I wanted to say has been said by Nehemiah.
Okay.
Yeah.
Thank you. What of John?
I wanted to request Jolene to repeat what she said about generating the true recursion.
Okay.
So what I'm saying is, in this case, I just come to you. I tell you, hi Anthony, hi Linda, hi Munyamekwa Mugine, hi Pichi. You can get something called the Fibonacci series. But now, you guys, you don't know what a Fibonacci series, you don't know even the sequence, how it goes, right? So you come to Python, you're trying to use the recursive method to get what a Fibonacci series is, right? The recursive method in Python is what you guys are defining. Define Fibonacci. Let's say I want to get the Fibonacci of an n number, a number that I don't know. Maybe it's 1, maybe it's 10, maybe it's 100. I want to know what that number will be in the Fibonacci series. So I use the recursive method, which is if n is less than or equal to 1, you return n. Else, return fib 2, right? So you have to print the results. Whatever number I enter there, maybe it can be 1. Atakama, like in this case, I think Linda can just Google. You see, there is the last cell there, you've written the Fibonacci series, right? Now that we know of it, you can try altering the above figures. Maybe you put another one. That just after 13 is 13 plus 8 is 21. So try putting n where n is replaced
with
7. You see, the recursive method will return that number, position 7 in the Fibonacci series. For 6, it will be 13, I think. For 7, it will be 21. For 8, it will be. So you are just generating the Fibonacci series using this method. And this method is what is called the recursive method. Hope I've been clear despite the movement.
Thank you.
Thank you, I've understood it. Thank you.
Is there anyone else? We've spent 1 hour on Fibonacci.
We are sorry, Linda.
No problem. That's the goal. Because why should you go ahead and you don't know even what a Fibonacci is? It's okay. Yeah. So what do we do? Because I've only talked about we haven't done linear search, we haven't done binary search.
we can do it maybe the other day.
Okay.
Maybe in this context, I don't know but I don't want to add anything though. However, if you could have gone maybe the other side. So essentially, someone tried to explain the purpose of the recursion.
Mm-hmm.
It's like to do something until you meet a certain, certain thing, a certain condition. Who was it? Jaylin. She explained it well. Perhaps she can repeat, and then I'll try to add on what she said.
Yeah.
On
And then
recursion.
Nema,
Yes.
when you're going to add in some more information,
I think. Oh, it will be okay. Sure.
let us just go up to
I see.
up to tomorrow. We're having 17 minutes to tomorrow. Hey, I've just been listening to you. I'm not feeling well. So I've just been listening. But,
Sure.
but thank you so much, guys. It has been a very good discussion. At least I've understood something. Until I've known we are doing hard things.
Yeah.
Thank you,
So
guys.
I think
Question,
let's prepare
guys.
for tomorrow.
Sorry for interrupting, Nehemiah.
No problem.
There was a time we did Saturday during the day. I don't know. I know it's hard for people, but I don't know if Linda is available, like from 11 or something. There was a time we worked during the day. We had a session and we really did. We did a lot. We covered a lot. So I don't know if she's available from 11. Then maybe we can do it during the day to be able to go a bit faster or to cover more ground. Because in the evening, I think time moves very fast. I don't know. It's just a suggestion. If she's able